Hello friends, welcome to the fourth chapter of the lecture series. In this chapter, we will learn how to model, how to analyze, and how to design a 3D frame. So far, we have done a beam which was in a single plane. After that, we did a 2D frame which was in two planes. Now we are doing a 3D frame which is in the three planes. As I have told you in the previous chapters, please make a configuration as per your requirement. For that, you have to go to the configuration, left click on the configuration, and from here, please choose the unit you want. Also, you can choose the background color if you want it white or if you want it black. Similarly, you can change the start default design codes. You can change them later as well. After making all the selections as per your choice, click on accept. Now what we do? Now let us open a new project. Click on new project option here. From here, choose space and the file name here we give as 3D frame practice. And from here, choose the folder where you want to save this file. As I've suggested, you always make a different folder for a file. And here you can change the units of the length and also the units of the force. You can change these things later as well, but if you make selections here, it will be easier for you to start. After doing this much of work, click on next and here choose add beam option. And after that, click on finish. Now I'll just close this window over here. We will not use this method to model our structure. We will define nodes from here. Now let us see what kind of structure we want to model for this chapter. It's blank here, but I will draw a 3D frame. Let's begin. So first I will draw a column and I'll provide fixed support. All the supports here will be fixed. There won't be any hinge or the roller support. Let me draw this structure. This is a column. I'll draw a beam and I'll draw the column again. I'll provide the fixed support. And here if I draw the axis, this is X, this is Y, and this is Z. Here you can see that I have gone in X, I have gone in Y. Now what we will do? We will go in the Z as well. And again, let us draw the columns. And here also, let us draw the columns. It's a very simple structure. Let me take this span as 5 meters. You can take any span you want. You can take 6 meters, 7 meters. It's up to your choice. And this span I'll take as 4 meters. And this span over here, I'll take as 3 meters. Let's do this span as 6 meters and this span as 4 meters. It will be a bit more clear, okay? So I'll draw this as 6 and this as 4 meters. Here only we got columns and the frames. We will not have any slab over here because drawing and designing the slab is very complex in Star Pro, and while applying the load we don't need the slab at all. That is why we will not be modeling the slab in this structure as well as in the building. I'll do a different chapter that will incorporate only the slab portion. Right now the slab will be omitted. It will not make any difference in the design of our structural members. Now let us model this structure in Start Pro. So let us go to Start Pro. Okay, one thing that you need to understand is while choosing the origin of your structure, make sure that all the Z portion or the X portion is positive. It will be easier while you want to apply different loads at different parts of your structure. To make Z and X positive here, you have to choose your origin at this point because Z is positive in this direction. Okay, in this direction Z is positive. That is why this node will be in the positive direction. Similarly, X is positive in this direction. That is why this node will also be in the positive direction, which means this node will also be in the positive direction. In case of building also, for example, if this is the plan of your building, so origin we will choose here, somewhere here, so that all the portion is in the positive direction. That is why we choose the 0, 0 node at this point. So this is our first node. This is node number 1. And next node, what we will do, we will choose this node as the next node. The distance from this node to this node is 5 meters in the X direction. So let us go to Start Pro. The first node, let us choose at 0, 0 and hit enter. You can see you got a node here. Now what we do, we just copy this node so that we get our second node. To select this node, first select this node's cursor. So left click on it. Select this node by left clicking on it. Left click here. After that, press Ctrl plus C. And after that, press Ctrl plus V. Now it asks where you want to paste this node. By the following X, Y, and Z values, we are copying this node in the X direction that you can see over here. This direction is the X. In the X direction, we want to copy this node at 5 meters from this position, which means that we have to enter 5 meter here and it is in the positive direction. Click on OK. After that, you can see you got a node here at a distance of 5 meters. Also, the coordinates are automatically defined for that node. Now what we do, we just select these two nodes. For that, hold Control and select this node, and after that select this node by left clicking on it, and again hit Control plus C and hit Control plus V. Now what we are doing, we are copying these two nodes in this direction, that is in the Z direction, so that we can get a node for this position as well as this position. The distance from here to here is 6 meters. So what we do, we go to Start Pro, and in the Z direction, that is the positive Z direction, we give 6 meters and hit OK. You can see that you got 1, 2, 3 and 4 nodes. Now again, what we do, we select all these 4 nodes. For that, you can individually select them, or what you can do, you can zoom out first, and after that just left click here, drag your mouse so that all your nodes are inside this rectangle, this selection rectangle. And once all the 4 nodes are inside the selection rectangle, release your left mouse button. You can see that all the 4 nodes are selected. Okay, now you can see that we have selected all the 4 nodes. What we are going to do, we are going to copy these 4 nodes
in this floor as well. I'll call this as a floor. For that, what we do, we go to geometry. You can either use Control C and Control V option, but that will be a bit complex. So what we will do, we will go to geometry menu, and here you can see the option Translational Repeat. You just left click on it. You can find this option here as well, Translational Repeat. And here it asks in which direction you want to copy these nodes. We want to copy these nodes in the Y direction. And here number of steps 1 means we want to copy this once. Default step spacing, the spacing here is this 4 meters. Okay, spacing from here to here, that is 4 meters. Input 4. The important thing that you have to do is over here click on link steps. If you do this, then automatically the nodes will be copied and the column will be drawn. After that, click on OK. You can see that the nodes have been copied as well as the columns have been drawn. If these nodes were connected by the beams, then the beams would have also been drawn in this position as well. But we didn't draw any beams here. Now we have to draw the beams here manually. For that, select this option. Okay, before that, save. Select this option, add beams option here, and left click on this node over here. Left click, and after that, left click here. Left click on this node again, and left click here. Left click, left, here to here. Now you can see that you got a frame. If you want to see the dimensions of the beams and the columns, what you have to do? You have to go to this option, dimensions, left click on it, and click on display. You can see that the height is 4 meters, the width is 6 meters, the width in the Z direction, and width in the X direction, that is the length, you can say, is 5 meters. I'll choose remove and click on remove. After that, click on close. Let me tell you that there are different other methods by which you could have drawn this frame. This is not the only method. You have to keep on practicing, and once we do the building, you will have known most of the methods, and you have to keep on practicing so that you can find your own method which you feel is the easiest one.
Now moving on, let us go to the General tab, and let us first define the beams and the columns. For that, let us go to the property option over here. Left click on the property that is already here. Alright. Now let us define the beams and the columns. Click on define. And we will be defining the rectangular beams and the columns. You can define the circular columns if you want. Let's go to the rectangular option and let us define the beams first. I will choose the lower values this time so that we can get the prominent shear force and the bending moment diagrams. The depth I will choose will be 150 mm, that is 0.15 meters, and the width I will choose as 100 mm or 0.1 meters. That is a very small size of beam, and click on add after that. Let us define the columns. The column I'll choose of 150 by 150 mm. Yeah, that will be sufficient, and after that click on add, and after that click on close. Here we have defined the beam and we have defined the column. Now what we do, we assign the beam and column to our frame members. First, let us select the beams. You can either individually select these beams, or what you can do, you can go to select option over here, and after that go to beams. Okay, let us save. Again, go to select option over here. After that, go to beams parallel to option, and you can see that the beams mean actual beams. So here beams refers to the beams and the columns both, but our beams are parallel to the x and the z direction. How? Because you can see that this direction is our x direction, and this is x, and this is our z direction, and you can see that these two beams are parallel to the x direction, and these two beams are parallel to the z direction. Similarly, if you have got multiple beams like 100 beams, all those beams will be parallel to the x and the z direction, and the columns will be parallel to the y direction. You can see the y direction is in this way. So these four columns will be parallel to the y direction, which means that to choose the beams you have to select beams parallel to x and the z direction, and to choose the columns you have to select beams parallel to the y direction. Let us go to Start Pro, and let us go to Select, and over here choose beams parallel to, and click on the x. After that, go to Select again, and go to beams parallel to again, and click on z. Here we have selected the beams. Okay, so I should have selected this option first. It will just go away. Okay, so I'll select this. It has gone again. Go to Select, go to beams parallel to x again, go to Select, go to beams parallel to z. You just do this, and here make sure that it is assigned to the selected beams option has been checked, and click on Assign, and after that click on Yes, and you can see that the R1 means the rectangular section 1 has been assigned to the beams. After assigning the beams, now let us assign the columns. For that, select this option, rectangle 0.15 by 0.15. After that, go to Select, go to beams parallel to, and click on Y option. You can see that all the columns have been selected. If you have 1000 columns, all those 1000 columns would have been selected. Now what we do, we use this option, assign to the selected beams, and click on Assign. After that, click on Yes. You can see that the rectangular section 2 has been assigned to the columns. So guys, this is it for this video. I hope it was helpful, and I'll see you in the next video. After assigning the sections, now let us assign the support for that. First, we have to define the support. So go to the support tab here, and click on Create option over here. After that, click on Add here. Here, as I've already told you, we got the fixed supports only. To assign the fixed support to our structure, first select the support. After that, we have to select the nodes where we want to assign this support. To select the nodes, go to the front view, that is view from plus Z, and left click somewhere here and drag your mouse. Drag your mouse such that make sure that the cursor selected here is the nodes cursor. Drag your mouse such that these two endpoints are inside the selection rectangle. After you reach here, release your left mouse button. You can see that these two nodes are selected. To ensure that all the nodes have been selected, go to the isometric view. Here you can see that the full nodes have been selected. Now what we do? We choose this option, assign to the selected nodes, and after that click on Assign, and after that click on Yes. You can see the fixed support has been assigned to all the 4 nodes. So guys, this is it for this video. I hope it was helpful, and I'll see you in the next video. After assigning the support, now what we do, we define the load and the load combination. So go to the load and definition option available here. After that, click on load case details, left click on it and click on add. Choose primary option here. Load number is 1, loading type. We are defining the dead load first. As the title is dead, you can name anything here, but it must represent a dead load. And after that, click on add. Similarly, we will add the live load. And a loading type is live. Click on add. For now, in this example also, we will use the dead and the live load only. In building, we will use dead, live and the seismic load. Click on close. Now let us define the loads inside the dead load. Click on dead option here and after that click on add.
Okay, save it.
Click on add. At first we assign the self weight. The direction is y and the factor is -1. Click on add. And after that the next load that we give is, let me show you. Okay. So here let us assume that these beams, these all 4 beams, this 1, 2, 3 and 4 beams, these all 4 beams have got a wall. This is our wall, okay? And let us assume that the load due to this wall is a UDL. If this beam is UDL, and let us assume that the intensity of the load is 10 kilonewton per meter. While doing building, we will see how this load intensity can be calculated. For now, let us just assume this value. This is the dead load that we are going to apply. Let us apply 10 kilonewton per meter load in these 2 beams. These 2 beams will have 10 kilonewton per meter load, and in these 2 beams we will have 5 kilonewton per meter. Okay. Now let us define accordingly. These loads are the member loads. So a left click on the member load and it is the uniform force. The force is -10 kilonewton per meter. D1, D2, D3, they all are 0 because we are applying the load in the entire span of the beam. The direction is GY, that is the global Y direction, and the minus means the downward direction. Click on add. You can see a load definition has appeared over here. Similarly, next load that we define is 5 kilonewton per meter load and click on add. Now we got 2 loads, 10 and 5 kilonewton per meter. So guys, this is it for this video. I hope it was helpful and I'll see you in the next video. Let us define the live load that we are going to apply as well. Let us assume that this is our floor here. This is our floor. And on this we are applying the live load of 2 kilonewton per meter square. Let us also assume that this is our live load, 2 kilonewton per meter square. This is the intensity. And let us also assume that we got a floor finish of 1 kilonewton per meter square. And this is our dead load. Here you have to see one thing, the Y range that this slab lies is, this is our 4 meter. This entire region is Y is equal to 4 meter region. Which means that if I take the region from here, okay, let me change the color. If I take the region from here up to somewhere here, like 5 meters. So this is 1 meter above our slab level. If I take the region from here to here, my slab will lie within this region. Is it? Yes, it is. Or what you can do, you can take from like 2 meters. This is 2 meters somewhere here. If I take from 2 meter to 4 meter, my slab will still lie in this region. To give these kinds of loads, you have to specify this region. Okay. Let me first define this dead load. For that, again, click on dead and click on add option. This load is a floor load. Save it. And the intensity is minus 1 kilonewton per meter square. Choose wide range option here, and here you have to define the range, define wide range, minimum and the maximum, which means that in wide range, which means that our wide range can be from 2 meters to 6 meters, 10 meters, 11 to 12, any higher value you choose. We will only have this slab, we don't have any other slab. But suppose that if this is our building, okay, this is the ground, and we got the first floor at 4 meters, we got the second floor at 8 meter, we got third floor at 12 meters. In this case, for applying the load in the first floor, the wide range should be any value from 0 to 4 meters. That is, I can take 1, I can take 2, I can take 3, and any value that is equal to 4 or greater than 4 but must be less than 8, which means that I can choose 4. So wide range here is 3 meter to 4 meter. If I give wide range, then this floor will be selected. So if I give 5 again, only this floor will be selected because we don't have any floor here. If I give 6 again, only this floor will be selected. If I give 7 again, only this floor will be selected. And if I give 8, then this floor will also be selected because wide range, this direction is Y, and this wide range value will cover this floor as well. So this is the concept of wide range, from where to where you want to apply the loads. So here our wide range should be, let us take the minimum value as 2 meters and the maximum value as you can use 4 meter as well. So it will still select the slab. So take 5 just to be in the safer side. Okay. And similarly, the concept of the X range also applies here. We got only one slab. That is why we got a full X range. Okay, we got a full X range, but suppose that we got 4 slabs and this is 1 meter, this is 2 meters, this is 3 meters. Okay. In the Z direction, this is 1, this is 2, and this is 3. Let us just suppose. And suppose that you want to apply 2 kilonewton per meter square load in this portion only. In that case, the X range is 1 to minimum value is 1 and the maximum value is 2, and the Z range is 1 to 2, minimum value is 1 and the maximum value is 2. And if you do that, only this portion will, or this panel will be selected. If you give the minimum value of X range as 2 and the maximum value as 3, for Z range, if you give the minimum value as 1 and the maximum value as 2, which means that this panel will be selected, and only in this portion the load will be applied. This is the concept of the range. Here, as we don't have any range for the X range because we are applying in the entire slab, we will give the minimum and the maximum values as 0, and same goes for the Z range as well. We click on add. Here you can see that you don't have any question mark in this load value, which means that you don't have to separately apply this load. Once you define the range and give the intensity of the load will be automatically applied. Now just click on close If you want to see this load, what do you have to do? You have to just left click on it. You can see how the load has been transferred to the beams. The ultimate goal of defining this slab is to transfer the load on it to the beams. Isn't it? Same thing is done by Stat Pro without even defining the slabs. Due to this reason, we do not define the slab because defining the slabs is very complicated and it will take a lot of time, and that is why we don't model the slabs in our regular building project. You can see how the load has been transferred to the beams and how the load has been applied on the beams. Now let us go to the live load and define the live loads that we are applying here. Left click on the live and click on add, and we are applying the floor load. We will define the live load of 2 kilonewton per meter square. Direction is global Y. The distribution is not one way, it is a two-way distribution. If you left click on it, you can see the live load has been applied and the live load has been transferred to the beams as well. So guys, this is it for this video. I hope it was helpful and I'll see you in the next video.